All right, my friends, welcome back. So we're going to learn today about area. Okay, so just to go back and do some basic review, this whole unit is going to be about area and volume. But if you have some function, let's say f of x, and you want to find the area under that function from a to b, we already know how to do that, right? The area from a to b is just integral a to b of f of x. But now, what if you have multiple equations, right? So what if we have an f of x, but what if we also have another function, g of x? And you want to find the area between them. So the area from there to there, just that area in there. Okay, now there are two ways you could do this. One is you could write this as, okay, so we could find the whole area under f, so integral a to b of f of x. And then we could subtract the area under it, so the area under g. So if we found all the areas added together under f and then subtracted all the areas under g, what that would do is that would leave us with just the integral a to b of f of x minus g of x, where again, this is our top function minus our bottom function. Okay, and that's a perfectly acceptable way to do that. Another thing you could do is think about this as like when you're doing this integral, you're just integrating the distance between them, that red distance being a top minus bottom. You're just integrating that distance all the way from a to b. Anyway, if you want to find the area between two curves, you just integrate f of x minus g of x. Okay, so now let's get some problems. Most of the problems in this, I'm going to give you a couple functions, ask you to find the area between them. Here's the process. Draw yourself a picture, find the bounds, integrate top minus bottom. All your area problems should be like this. So if I just give you, okay, like here is y equals x, and then here is e to the x, which is going to look like that. And you're trying to find the area from 0 to 1. So what that's saying is, okay, here's 0, here's 1. What is the area inside there? All right, well, what we're going to do is we're going to set this up. So we have e to the x on top, we have x on bottom. So this is our top function, and this is our bottom function. And when we integrate this, we're going from the left bound to the right bound. So we're going from 0 to 1 of top minus bottom, so that's e to the x minus x. Okay, so that's how we're going to find the area between those two curves. Now, this integral is pretty straightforward, right? You could do this by hand. So this just becomes e to the x minus x squared over 2, going from 0 to 1. So when I plug in 1, I get e to the 1 minus 1/2. When I plug in 0, e to the 0 is 1 minus 0. So I will just get e minus 3 over 2. Okay, and there you go. That's how we do that. That's how we'll find that area, and that's what that area is. Beautiful. Okay, so that's how we're going to do it. Now what I'd like to do is give you a moment to try these on your own. So go ahead and pause this video and do problems 1, 2, and 3 on your own. I would say it'll probably take you roughly 8 minutes for that. Okay, so hopefully you paused and had a chance to do these problems on your own. Let's go ahead and go through them quickly. All right, so if you have two curves that intersect like this, what you have to do is set them equal to each other to find where they intersect. So they're intersecting when 2x equals x squared. So when x squared minus 2x is equal to 0. So x times x minus 2 equals 0. So that happens when x equals 0 and x equals 2. Okay, so anyway, when you actually need to find that area inside here, that area is just integral 0 to 2 of top minus bottom. And we can see from the picture that the red curve, the line is on top, so you'll get 2x minus x squared. If you accidentally put the wrong one on bottom, and you switch the order, you'll just get a negative sign, which makes no sense. So I'll just go back and flip the order. Anyway, you work that out and you get 4/3. All right, so let's go to another one. This is one I asked you to do, and you'll have to use your calculator for this. So what you have is you have x squared minus 4, which looks something roughly like that. And then you have ln x plus 2, which looks something roughly like, what does it even look like? Yeah, something like this. Something like that. All right. So anyway, what you have to do is find these two bounds first. So you'll do second calc intersect. So these bounds here are going to be x equals negative 0.168, negative 1.685854, and x equals 2.338263. One tip I want to give you on these, and this is going to be very calculator calculator heavy chapter. In your bounds, you need to put 5 or 6 decimal points. I recommend 6, but at least 5. Because in your answer, remember you need to have 3 decimal points, and all 3 of those need to be correct on the AP test. And if you want to make sure that you don't have any rounding errors, you need to make sure you use 5 or 6 in the bounds. The more the merrier, honestly. So you can have a mistake, you can have a rounding error if you don't use enough decimals. So make sure you use enough on each of these. Okay, and your calculator should give you at least 6. So when you want to find the area here, you look at this area. This area should be, okay, so left to right, so that's negative 1.685854 to 2.338263. So I'm going left to right. Again, I'm going to do top minus bottom. Okay. So I'm integrating here. We see the ln x plus 2 is on top, and then you see the parentheses, the parabola is on bottom. So you'll plug this in your calculator, and I got 12.9438. Okay, now this area looks like this, and I asked you the question, do you do anything different because it's under the x-axis? And of course the answer to that is no. Right, the math is the same. Whether we're above or below, it's the same area. We're still integrating our top function minus our bottom function. Okay. So let's go on to the back side now. The back side then on the next one, when you graphed this function, you probably saw there were actually 3 different points of intersection, right? And what I got on these, I got x equals negative 3.05388, x equals negative 0.11058, that's cute, and then x equals 2.94396. So you have to do 2 different integrals because we have 2 different areas, right? We have one area here where the blue curve is on top and one area here where the red curve is on top. So I need to split that up because I have a different function on top which becomes the bottom function on the next one. So when I split these, the integral on the left, I need to go, okay, so integral negative 3.05388 to negative 0.11058. Okay, and there I see the red curve is on bottom. That's the cosine. So that's going to be x cubed minus 9x. Why is it like this? X cubed minus 9x on top minus cosine x. Plus, because I'm adding together the 2 areas. Now for my next one that I'm going to find in here, my next one, I'm going to go negative 0.11058 on to 2.94396. And I'm going to do top minus bottom here. Now I see the red curve is on top. So that's what I need to put first. So that's got to be cosine of x minus parentheses x cubed minus 9x. All right. Anyway, you do this on your calculator. The answer I got when you add the 2 integrals together was 40.665. If you didn't get that, double check your work. You probably typed something in wrong. Maybe you're in degree mode or something. Okay, so that's how we're finding these areas, doing top minus bottom. The next thing we need to think about is going sideways. So what we're doing here is we're going to do integrals in terms of y. Okay, so you're probably not used to thinking about this because it's a little bit different, but the setup is going to be pretty similar. So the usual in terms of x, we do integral from the left bound to the right bound, and we do the top minus the bottom in terms of x. Now what we're doing here is we're actually going sideways. So if we're doing this in the other direction, we're going from like the bottom to the top, and we're doing like a right minus left. So we have something in terms of y. What you're going to do is you're going to go, okay, integral from the bottom, from the bottom to the top, and you're going to do the right function minus the left function. So it's like a top minus bottom, right? You can turn your, if you turn your head 90 degrees to the side, you see the right one is the one that's kind of on top, if you will. So that's like your right function. That makes sense because the positive side's on the right side, just like the positive side is on top normally. The negative y is below, the negative x is the left. So what you're doing in this case is you're just trying to find this area. Now at top minus bottom, we see it doesn't work because in part of this area, the top and the bottom are the same function. That's super confusing. And because these functions are written in terms of y, that's what's telling us that we need to do this integral in terms of y. So the way we're going to find this area and set this up is we're going to set this up as Okay, so the integral from the bottom to the top, so my bottom bound is down here, that's at y equals -1, to the top bound here at y equals 3. Okay, and what you're doing again, you're integrating the right function minus the left function. And if you draw a line across at any point in time, you see that the right function is the one in blue. That's this -y² plus 10. So that's like the -y² plus 10 minus, and then the left function, that's the red one, the left function is parentheses y minus 2 squared. Okay, so that's how you would do this integral in terms of y. And you're generally, like, if it's in terms of x, you're generally not going to do this, but if they give you the functions in terms of y, you need to be confident doing a right minus left like that. Okay, now there's one other thing also, and obviously you can plug this in your calculator. If you plug in your calculator, by the way, just pretend they're y, or sorry, pretend it's x, just type in as x, the answer will be the same. It doesn't matter when you integrate. Okay, so now let's go to another example, and this is one you can actually do in two ways. This is one you can do in terms of y, so I'm going to show you that, but you can also do this in terms of x. So let's suppose we have to find the area between ln of x and 9 minus x. So you graph these on your calculator like a good little soldier, and here's ln of x, and then 9 minus x, of course, is just a straight line like that. Okay, so what you're trying to find, the area between ln x, 9 minus x, and the x-axis, that's this area in here. Now again, you're a good student, and you look at that, and you're like, oh crap, there is no top minus bottom. But if I turn my paper sideways, or think about it sideways, do we have a right minus a left? We do. Oh my goodness. We can do a right minus a left. Okay, so let's go ahead and do that. So what we're going to do in this case, this is y equals 9 minus x. This is y equals ln x. If I want to do in terms of y, I need to do a right minus left. But what I also need to do is I need to write these functions in terms of y. In the last one I'd given it to you, they were already written in terms of y like that. So what I need to do is I need to solve these for x equals. So in this case, if I have y equals ln x, I can raise e to the power of both sides and get x equals e to the y. So I could think about that as y equals ln x, or I could think about it as x equals e to the y. Similarly, I could solve for x here, so I could say x plus y equals 9. So x equals 9 minus y. Oh, that's cute. Okay. So when I'm doing a right minus left, I need to do it in terms of y. It's going to be dy. So if I think of this as like a right function minus a left function, I can think of that area as, okay, so I'm integrating a right minus a left. My right function is 9 minus y. My left function is e to the y. Okay, and my bounds here are y equals 0 is at the bottom, right? But then what is the top bound? I need to find that intersection point. Okay, so I'll graph those on my calculator, and I'm going to show you that. So graph them on your calculator. So we're going to graph e to the power of x, ln of x, my bad. So we're going to graph ln of x, and then we're going to graph 9 minus x. And when I graph both of those, I'm going to find the intersection. But one interesting thing there is when I find the intersection, your calculator gives you the x and the y. And both of those turn out to be useful. So what I got here is 7.04734, comma, 1.95265. Okay, that did not work out very nicely. 1.95265. Okay, pretend that's a 5. So what that means is if you're doing it in terms of y, your top bound is the y coordinate. It's what is the height right there. So you're going from 0 to 1.95265. Okay, so anyway, what I'm going to do now is I'm going to plug this in my calculator. So when I find that area on my calculator, I'm going to integrate this and say, okay, I'm going to math 9 to integrate. But I'm just going to type it in terms of x. I just do 9 minus x minus e to the x. Luckily, it doesn't matter, right? Math is math no matter what variable. And I go from 0 to that y point. So 1.95265. So I want to write it down in terms of y with my right function, my left function. But on my calculator, I write it down, and I get 9.62009. Okay, So that's how you do it in terms of y. You need to find your right function, you need to find your left function. And I had to like solve for x in both these, right? I got it as x equals and x equals. And then I could do a right minus left integral. Cool. So that's how you do this problem. It turns out there's actually another way to do this problem. So you could also do it in terms of x, but again, there's no top minus bottom. So what I have to do is I have to split this up into two different integrals. So I have to basically split it like that, right down there, and say I'm going to find the area under ln of x plus, and then I'm going to find the area under the line like that. So I could split this up to be integral from 1 to 7.04734 of ln of x plus, and then I could go from 7.04734 to 9 of 9 minus x. So both, it's not like a top minus bottom, so I need to do two separate integrals. So I want to show you there are multiple ways to do these problems, but sometimes it might be really useful to be able to turn this in terms of y and to do a right minus left type thing right there. Okay, so that's area in terms of x and in terms of y. Bring me questions to class. I'd love to help you guys out. Thanks for watching. Wrong button.